This video walks through the core of JavaScript, the language that runs in every browser and, thanks to Node, on the server too. We'll cover variables and types, control flow, functions and scope, arrays and objects, and how to handle errors without crashing your program. By the end you'll have the full toolkit Level 1 is built around. Let's start with how JavaScript stores and compares values, the vocabulary everything else in the language is built from. JavaScript gives you 3 ways to declare a variable. Use const by default, since it can't be reassigned. Reach for let when a value genuinely needs to change. And avoid var. It's scoped to the whole function instead of the block, which causes subtle bugs. JavaScript has just one numeric type for both whole numbers and decimals, plus strings, booleans, null for an intentional empty value, and undefined for a variable that was declared but never assigned. The typeof operator tells you what you're working with, though it famously reports null as object, a quirk baked into the language decades ago. For comparisons, always reach for triple equals and not triple equals. Double equals will quietly convert types before comparing, so 5 loosely equals the string 5, and that coercion is a common source of bugs. Triple equals checks the type too, so it only matches when both sides truly match. You'll often need to convert between types on purpose. String and number wrap a value to convert it explicitly, parseInt pulls the leading digits out of something like 42px, and boolean tells you whether a value is truthy or falsy. Speaking of that, only a handful of values are falsy in JavaScript: false, 0, an empty string, null, undefined, and nan. Everything else, including a non-empty string or any object, counts as truthy in a condition. With variables, types, and comparisons down, we're ready to make decisions with them. That's control flow. Now that you can hold and compare data, let's control what your program actually does with it: branches and loops. The classic if-else chain picks one branch to run based on a condition. Here we turn a numeric score into a letter grade, checking from the highest threshold down. For a quick two-way choice, the ternary operator packs an if-else into one expression: condition, the value if true, the value if false. It's perfect for simple assignments like this vote eligibility check. A standard for loop counts with an index. But for arrays, for is usually cleaner, it hands you each value directly. For in is different, it walks over keys, which is more useful for objects than arrays. Break exits a loop entirely the moment you've found what you needed here, the first multiple of 7. Continue just skips the rest of the current iteration and moves on, which is how we skip every odd number in this loop. Switch compares one value against several cases using strict equality, and falls through to the next case unless you return or break that's actually useful, like grouping Saturday and Sunday together as weekend here. Now you can branch and loop next. Let's wrap that logic into reusable functions. Functions are how you package logic to reuse it, and scope determines which variables that logic can actually see. A function declaration is the most familiar form, and it supports default parameters, so calling greet with no argument still works, falling back to friend instead of throwing an error. Function expressions assign an unnamed function to a variable, and arrow functions shrink that syntax further. No function keyword, an implicit return for one-liners, and notably, no binding of their own, which matters once you're inside objects and classes. The rest parameter, 3 dots before a name, gathers any number of extra arguments into a real array, so a total function can accept as many numbers as you throw at it and reduce them into a sum. JavaScript hoists function declarations completely, so you can call one before its line in the file. Var is hoisted too, but only the declaration, not the value, while let and const sit in a temporal dead zone where touching them early throws an error. Each function creates its own scope, and a nested function can read variables from every enclosing scope around it. Here, 3 different x variables coexist peacefully because each one only shadows the outer one inside its own function. With functions and scope in place, we can talk about the data structures you'll pass into them: arrays and objects. Almost every real program is about moving data around, and in JavaScript that data usually lives in arrays or objects. Arrays are ordered and mutable. Push and unshift add to the end or start, splice removes from the middle, and pop removes and returns the last item. The modern .at -1 is a clean way to grab the last element without doing length -1 math. Map, filter, and reduce are the workhorses of array transformation. They all return something new without touching the original array. Map transforms every item, filter keeps only what passes a test, and reduce folds the whole array down into one value, like a running sum. Array destructuring pulls values straight into named variables in one line, and the rest of an array can be gathered with 3 dots too. The spread operator does the reverse. It expands an array's items into a new one, which is how you copy or combine arrays without mutating the source. Objects store key-value pairs. You can read and write properties with dot notation or bracket notation. Bracket notation is what you need when the key itself is dynamic. Object.entries, keys, and values all give you different views for looping over what's inside. When you need guaranteed unique values, reach for a set. When you need frequent additions and removals by key with guaranteed order, reach for a map instead of a plain object. Both are purpose-built tools worth knowing alongside arrays and objects. We've covered how to store and shape data. Last piece, what happens when things go wrong? No program handles perfect input every time, so let's look at how JavaScript lets you catch problems instead of crashing. Try/catch wraps risky code here, parsing text that isn't valid JSON. If it throws, execution jumps straight to the catch block, where the error object tells you what went wrong through its message property. JavaScript doesn't have typed catch clauses, so you check the error yourself, or better, validate before you even get there, like this safe parseInt function, which checks number.isNaN and returns null instead of letting bad input propagate. A finally block runs no matter what, whether the try succeeded or the catch caught something. That makes it the right place for cleanup code you always want to run, like closing a connection or logging that an operation finished. You're not limited to catching built-in errors. Throw new error with your own message anytime your own code hits a condition it can't recover from, like trying to withdraw more money than a balance holds. Every error object carries a name, a message, and a stack trace you can log while debugging. Keep in mind try/catch only sees errors thrown synchronously. Errors from callbacks or promises need different handling, which Level 2 covers in depth. That's a complete tour of JavaScript Level 1 variables and types, control flow, functions and scope, arrays and objects, and error handling. Every example here is straight from the JavaScript Mastery Path, linked below in the order we covered them, so you can read the full lessons, run the code yourself, and work through the exercises at your own pace.